This video is specially prepared for Asia Virtual Innovation Competition 2023. Now let's introduce the team members. Starts with our leader, Puan Siti Hajar, Nabila Adila, Dr. Zaki Yusuf, Puan Madia, Puan Noor Sham, and lastly Puan Norha. Now, without any further ado, let me introduce our research and innovation, titled on Development of High-Efficiency Gallium Arsenide Solar Cell with PC1D Simulation Software. Before we jump deep into the research, let's watch the clip provided.
Climate change is a critical concern facing humankind today. We are approaching an unprecedented era where ignorance and inaction is not an option.
We're fast running out of time. We've got to go for the gigatons. There's 59 gigatons per year of greenhouse gas emissions, and that number is growing. We have to drive that number, Harry, to net zero by 2050. And we have to get halfway there by 2030, which is just 8 years from now. That means this coming year in 2022, to be on track, we need to reduce planetary carbon emissions by 8%. And then another 8% in 2023, in 2024, in 2025, to get to a cumulative 50% reduction by 2030. Do you know how many times we've reduced carbon emissions on the planet to date? Never. Never. So what do you think are the odds we're going to pull this off?
Here are the outlines going to be covered, especially on problem statement and main findings. What is the significance of this study? In this study, the overall goal is to develop high-efficiency gallium arsenide solar cell with PC1D simulation software. Further study and research were inspired as Malaysia has adopted the Paris Agreement and committed to a 45% reduction in emissions intensity of GDP by 2030 compared to a 2005 baseline, TO, 2020. The current need for net zero carbon emissions acts as a strong incentive for the development of technologies that reduce risk of climate change as the main output for sustainable applications. Next, what is the issue? It is the conversion efficiency of the existing PV technologies are less than 23%, indicating the need for further developments to provide increased competitiveness, Alami et al., 2022. Why is this study or innovation conducted? This is because, first, to study the influence of parameters such as thickness and doping concentration at NP region, and surface recombination velocity of both front surface recombination velocity, FSRV, and rear surface recombination velocity, RSRV, on IV characteristics. Second, to achieve high efficiency of absorption rate via gallium arsenide solar cells. Third, to produce the ideal gallium arsenide solar cell coating using PC1D software. But, why gallium arsenide? Why? This is because of its features of high efficiency, thin film, excellent temperature coefficient, radiation resistance, and multi-junction application potential. Next, it has a direct bandgap, strong electron mobility, and a high absorption coefficient that can work at high temperatures. Direct bandgaps are desirable due to their high absorption coefficients, thin absorbers, and low material input. Let's move to methodology. These are the visualizations of the methods used on PC1D simulator. These is the basic parameters used from Singh et al., 2022, at 22.79% efficiency. Here comes the crucial part of this research, the main finding observed at the different thickness and doping concentrations at both N and P regions, and also the recombination velocity at the front and rear surface. These are the data analyzed from the IV curve characteristics. Finally, every parameter at the highest efficiency is combined to develop an optimum efficiency of the gallium arsenide solar cell. The optimized values achieved at 28.82%, which contributes 5.49% increment. This research can be commercialized as components to improvise for the R&D and fabrications. The novelty comes as the parameters observed and the higher efficiency achieved compared to the reference research by Singh et al., 2022. That's all from us. Thank you.